Welcome back. We are on Module 7, where we're going to be talking about distributions for quantitative data. And the first thing we want to talk about is the steps of a statistical investigation. There are 3 steps you want to consider when you're talking about a statistical investigation. And the first is you want to produce data. You're going to determine the variable that you're going to measure and then collect the data. And then you're going to explore the data. You're going to analyze it. You're going to analyze and summarize the data, which is also called exploratory data analysis. And then finally, you're going to draw a conclusion. You're going to make an inference using the data, and then also probability. You're going to make a statistical inference to draw a conclusion about the population. What happens is you have this question that you want to answer. And so what you do is, to answer that question, you think about what is it that you want to measure, and then you go and you get the data. And then once you have the data, then you analyze it. And then once you've analyzed the data, you make an inference to the population. There are a couple of different types of variables that we work with. One is called quantitative, and one is called qualitative. Quantitative is like quantity. It's also called numerical. Qualitative is quality, which is also called categorical. I prefer categorical and numerical because I have a hard time saying qualitative and quantitative sometimes. And I also have to think about quantitative is quantity, which is numbers, which is numerical. And numbers and categories just are a little bit easier for me to remember right off the bat. But they're synonymous. Typically, when you're talking about numbers, they are typically quantitative, not always. There are numbers that are actually categorical. You want to think about quantitative variables as things that it makes sense to find the average of. Does it make sense to find the average age or the average weight of someone? Numbers that it doesn't make sense to find the average of are something like zip codes. It doesn't make sense to find the average zip code that tells you where you're, in Middle America. Zip codes are categories because they are giving you a region, just like area codes. Area codes are telling you the region in which someone is located. So just because it's a number does not always mean that it is numerical. Categorical could be zip code, but also could be like eye color, car type, different things like that. There's a learn by doing on page 29 that gives you a list of serials. There are 77 serials that are included in this, and we're going to do a little bit of analysis on these serials. Considering this table that is a snapshot that is an OLI, we want to know what are the individuals that are being described, how many are there, and how many variables are categorical, and how many variables are numerical. The individuals that are described here, it's not actually an individual. I'm not talking about a person. I'm talking about cereals. So these are breakfast cereals. And even though we are told that there are 77 cereals in this data set, we're actually only working with the 7 that you see here. So it says how many individuals are shown in the screenshot. There's 7. And then we're asked how many variables are shown in the screenshot. Well, we're told the manufacturer, the target, the shelf, the calories, the sodium, and the fat in this screenshot. We're also told the name, but that's not necessarily a variable that we're talking about. That's identifying the individual. So there are 6 variables. The categorical variables are the ones that describe the category that it, again, it may be a number, but it's just a number that it doesn't make sense to find the average of. The manufacturer is categorical, the target audience is categorical, and the shelf is categorical. The numerical variables are calories, sodium, and fat, because it makes sense to find the average calories in the cereal, the average sodium level, the average fat. It's not the only way to determine whether something's numerical. That's just what I think of when I'm trying to determine whether something's categorical or numerical. Our next question asks us, what is a distribution? When I'm asking you to describe a distribution, which is something you will be asked, I will ask you to describe a distribution, and I'll give you a distribution. What's a distribution? It is the collection of data for a specific variable. I don't mean collection as in getting. I'm not collecting things. I mean collection as in I have a collection of shoes. That's my shoes. The collection is the group of data that we have for a variable. So what are all of the numbers that we have for the calories? What are all of the numbers that we have for sodium? What is all of the different options for target? That would be the distribution that we're talking about. In the Did I Get This on page 30, it says that in this research, in this study, researchers investigated the lifespan of animals living in captivity. And they gathered data on 30 different species of mammals. The lifespan is the age of the species in years. So how long did the animal live? And they want to summarize the distribution of lifespan. So they want to summarize all of the different ages that they gathered. In graph A, we're given on the left-hand side the lifespan in years, and then the cage number on the x-axis. In graph B, we're given the count on the left-hand side and the lifespan in years on the x-axis. And they ask, which graph is better for summarizing the distribution? Well, graph A with the cage numbers, that doesn't really help us, and we see the different ages fluctuating. It's not a really good picture. Graph B is the better picture. We're asked to determine whether the statements that are given here are accurate or not. And so we're going to use graph B to help us answer that. The first question says, a typical lifespan for species in this group is 12 or 15 years. Typical, as you'll come to learn, is talking about the average value or the middle value. And so is the middle value around 12 to 15 years? If we look at this graph B, 12 is this one and 15 is this one, and it's right in the middle, and it does have like the highest peak. So I would say yes. And of the 30 animals, there are 1, 2, 3, 4, 5, 6 in the 12-year category and 5 here. So 11 out of the 30 were either in the 12 or the 15-year group. So definitely. Lifespans ranged for a year to 30 years. 1 year here, that's true. And then 30 years here. That's not true. I have a lifespan of 40. It goes from 1 to 40, not from 1 to 30. So this is not true. Then over half the species lived from 12 to 20 years, or exactly 20 years. Well, let's count. We knew that there were 6 that were in the 12 years, 5 that were 15 years, 1 that was 16, or maybe 18. 1, 2, 3, 4, 5 here. So 5 plus 1 plus 5 plus 6 is 17. That's more than half of 30. And then lastly, it says it's unusual for an animal to live longer than 25 years. Going back to the graph, putting a marker here, 25 years is here. And it says it's unusual to live longer than 25 years. There's only one that lived longer than 25 years. So I would say yes, 1 out of 30 is unusual. And we will get more specific as to what is unusual as we move forward in this class. We're going to move into Statcrunch now. And so I'm going to show you in the next video how to use Statcrunch to create graphs. In the guided notes, you'll see that there are directions. I will be saying those directions as I perform them on Statcrunch.